Hi everyone, welcome to BYJU'S exam prep civil mechanical and EXE YouTube channel. And in this class, as you can see the title and the thumbnail, we are going to talk about top 10 most expected questions for your BARC 2023 for civil as well as for mechanical. So please quickly let me know in the comment box if you all are super ready for solving these 10 questions with me, and also let me know if my audio and video is perfectly fine for all of you. So hi everyone, कैसे हैं आप लोग? Hi Kiran, good evening, welcome to the session. How is everybody? Please share this session with your friends, and if you are new to our channel, do not hesitate in subscribing the channel, because we are having a lot of beautiful videos on this channel that may clear your concepts on another level. Moving on to a quick introduction about myself. If you are here for the first time and you are watching me for the first time, so here's a quick introduction. My name is Joshit Singh and I have 4 years of teaching experience now, which is about to be 5 years in this month. And my qualification is I'm MTech from IIT Roorkee, and my specialization is also in hydraulic engineering, which is fluid mechanics, open channel flow, hydraulic machine, some part of irrigation, some part of hydrology. So these are the things that we cover, and a lot of other things which is not there in GATE, like glaciology as well. Yes, we have studied glaciology also in our MTech. So I think we are here with the directly first question. I believe in wasting zero time, so that's the reason. There's the first question in front of you. It would be great if you can quickly answer in the comment box about this question, everybody. Yes, please read the question and then tell me the right answer. Come on everyone. So the question says, the boundary layer thickness at the trailing edge when a flat plate of 10 cm wide and 55 cm long is placed longitudinally in a stream of fluid whose kinematic viscosity is 1 stroke, okay, it should be stoke, not stroke, flowing with a velocity of 8 meter per second. I think the top bar is not visible to the students, so no issues, but the question is visible. So please try to answer this question right now. Right, okay, quick everybody. Okay, so quickly please answer this question, guys. Chaliye, I'll also start solving the question for you. Okay, so first of all, we need to understand what they're asking. So they are actually asking us the boundary layer thickness, I suppose. So if we need to find the value of boundary layer thickness, we can use the Blossier solution. But in the Blossier solution, we need to understand that what type of flow it is, what type of boundary we are having. For that, we need to find out the local Reynolds number. So let's just find out the local Reynolds number, and then we will get to know the exact value of the boundary layer thickness. So here, let's find out the Reynolds number. So Reynolds number is very simple over here to find out. We are finding out for the entire plate only. So it should be mu VL by rho, but since we have kinematic viscosity, so VL by nu will work out for us. So can quickly please anyone tell me what is the value of local Reynolds number? Thank you Saurabh and Kiran. Okay, let's see that. Good evening. Mera rank 386 hai. OBC categories, PSU. Yes, this year though I think there are a lot of PSUs and students who are having rank somewhere around 400 also. So they have a chance that they may get, but it all depends upon two things. First, how many students are opting for MTech that are there below 400 rank. Number two, if someone is taking 2 seats in in 2 different PSUs, same student is if covering 2 seats. So you may have to wait till the waiting list is released, but yeah, there is a good chance that you may get. So how much is the value, everybody? Is it 4.4 10 raised to the power 4? So if it is 4.4 10 raised to the power 4, so can I say that this is actually what? This is obviously less than 5 into 10 raised to the power 5, which is the critical Reynolds number. So this particular case is nothing but this is the case of laminar boundary layer. Now we know that for the laminar boundary layer, we have the Blossier solution given by obviously Blossier, and that solution is super simple and it goes something like this, that your boundary layer thickness, which is del by x. Now somewhere it is written 4.9, somewhere it is written 5. So it is up to you. You can go with anything. Both are correct only. So we'll go with 5 only. 5 upon under root REL. So we'll put the values and we'll get the answer. So x will nothing but it will be L only. All the values are given. The I think 10 centimeter by 55 centimeter long is given. What else is required? Velocity is given. I think we have already got the value of REL. So how much is the boundary layer thickness? Very good. Ayush has also got the answer. Just a minute. Okay. So it should be somewhere around. I'm not wasting time in the calculations, right? So yes, you are correct. The answer that you should tell me is 1.3 centimeter. If you will write down 1.311 in the examination, there is a higher chance that you may get 0 marks. Why? Because they are already mentioning you this, that it should be round off to 1 decimal, right? So with this question, we learned 2 things. One is the concept, and second is this one thing that you always have to look at the bracket. Everyone super fine? Any doubts? Anybody? Can I move to the next question now? Okay, let's move to the next question then. Here we have the next question. The flow of water whose mass density is given, kinematic viscosity is given, a compressible pipe with equivalent roughness is given, yields average shear stress at the pipe boundary as this much. The value of Ks by del dash, where del dash being the thickness of laminar sublayer for this pipe is how much? Everyone can answer this, I think. Tell me. But sir, question will be MCQ. But I think here, ठीक है, BARC में obviously yes, it is MCQ. Very good point. But I was telling in terms of NET, if somewhere it comes like in GATE also. But yes, you have a valid point. There you will always have the options. But I have got the questions where some questions have some NET also. Okay, so that should not be the concern, I suppose, right? Please answer this question now. Boundary layer, thickness of laminar sublayer, right? Del dash. So I suppose you guys know the expression for this as well. Sir, mechanical में 633 पर PSU मिल सकते हैं. यार 633 तो थोड़ा सा मतलब I would say in a higher side. It's a very good rank, but still for PSU it is on the higher side only. I will always suggest to all the students who are having rank more than 200 or maybe 300 that always go for all the options. ठीक है, you will have to pay some money in the registration fees and all, maybe in IITs or other places. ठीक है, bear that much money at least, कोई बात नहीं, right? If some student is there whose financial situation is not that also good that they can pay 500 rupees or 100 rupees of the IIT fees, but they are having a decent rank, then please tell me, I will pay the fees of this 500, 100,000 जो भी fees है मैं pay कर दूंगा, ठीक है, वापस भी नहीं चाहिए. But all the point here that you should not waste your rank just because you are confused, right? सब जगह apply करो, ठीक है. MTech अच्छी जगह, like suppose you are having 633, तो करो apply. MTech में भी करो, अच्छा college जो होगा IITs में. Then PSU if you are getting, there also try to apply. Once you get one PSU, then leave the others. फिर उसको छोड़ दो, बाकियों को भी लेने दो, right? But लगता है कि नहीं यार फीस देनी पड़ेगी IIT में भी उतना नहीं है मेरे पास, तो मैं दे दूंगा 110% एनी टाइम. मेरे को बस बता देना दैट यू नीड इट. बताइए सर, हाउ मेनी ऑफ यू गॉट दिस? द फ्लो ऑफ वाटर. ओके, सो द वैल्यू ऑफ Ks by del dash basically is required 11.6 nu by u star, correct? And Ks is given, del dash we know. Okay, nu is given. So how to get the shear velocity? Tau by rho. So is it given? Tau is given. I think yes, it is given 600, and density would be 1000 only. देखो जरा how much you are getting the value of shear velocity. Right, so tau naught is how much? Tau naught is 600 and this is 1000. Is it water? Yes, it is water. So from here you will get the value of the shear velocity. Shear velocity whatever you get, and Ks is given to us as 0.12 mm. Ks भी हमारे पास. Nu we have 10 raised to the power minus 6. So I think everything we have now, whatever is required to find out Ks by del dash. आयुष ने बोला है ऑप्शन डी इज करेक्ट. अदर स्टूडेंट्स, बाकी लोग भी बता दीजिए. थैंक यू सर फॉर. अरे एनी टाइम एनी टाइम बताइए सर, एवरीबॉडी. Ks by del dash basically you want. Right, Ks is given, del dash is that value where U star we have found out from here only, right, whatever it is going to be, 6 by 10 या 0.6 जो भी करना है आप कर लो उसको accordingly, and this value should come somewhere around 8.01 and option D is correct. किसने निकाला था? Kiran and Ayush. Very good guys, very good, amazing. Let's move to the next chapter also and next question also. This would be I think third question, correct? You can like the session also if you are enjoying and if you are actually getting the concepts. Okay, cool. This is the third question now. Okay, this is third another chapter also and third question. A cylindrical, okay, it should be a body. A cylindrical body weighing 19.62 kilonewton. So this is the weight of the body given to us, is floating in ocean. The body has a diameter of 2 meter, is 2.5 meter high. So length is given and dia is given. The body is in stable equilibrium, unstable, neutral, can't say. So what is that one factor that we need to find out here to understand which option is correct here? Can anyone tell me what is that one thing that we need to find out which can tell us that which equilibrium this particular case is? बोलो एक बार फटाफट एक बारी. That's yes, that we have to find out the GM value, metacentric height, right? That is I by V displace minus BG. Okay, so we need to find out the displaced volume, and then we have to find out I, then we have to find out BG. For BG, we need to find out depth of immersion also. But remember one thing, they are saying a cylindrical body weighing 19.62 kilonewton is floating in the ocean. So accordingly, please try to answer. Everybody, take your time. कोई जल्दी नहीं है. So first of all, you can find out how much is the volume displaced, right? And from there you can find out the depth of immersion because you know the dia. So we know that depth of the bind force should be equals to the weight of the body, right? And that is what? That is I think rho GV of body will be equals to rho GV displaced, correct? Rho G is given to me as 19.62 kilonewton. Cool. And I think volume also we can get, right? G तो इधर भी आ गया, ठीक है. Then volume we can find out equals to, here density is given 1020, 9.81, right? And V displaced. Can anyone tell me what is the value of displaced volume? One 1.96, right? A meter cube. अच्छा आंसर भी आ गया. स्टेबल इक्विलिब्रियम. आर यू श्योर? देखो वॉल्यूम शुड बी, डिस्प्लेस्ड वॉल्यूम शुड बी 1.9 meter cube, and from here depth of immersion, let me call it H only, would be 1.9 divided by pi by 4. What is the dia? 2 meter, 2 square. तो ये तो यहाँ से गया 1.9 by pi. How much it is? 1.9 by pi. It's a 0.624. So 0.624 is the value of depth of immersion. So from here now we can find out a lot of values like BG can be found out. BG कितना आएगा देखो, So BG would be CG will be 2.5 by 2 minus then we want CG aa gaya. Okay, now we have this 0.624 by 2. From here the value of BG would come and it should be, let me tell you, 0.938. Please check the calculations. Okay, I'm not very much into the calculation and all, right? I'm here to tell the concept. Still you can please check. Okay sir. Now BM, okay cool, BM is nothing but I, that is pi by 4, like how much, pi by 64 d raised to the power 4 will be using over here, right? Pi by 64 d raised to the power 4 by displaced volume pi by 4 d square h is the displaced volume minus 0.938. Sir, this should come somewhere around minus 0.538, isn't it? Is it minus 0.538? If it is minus, so obviously metacentric height is less than 0, means it is unstable. Okay, okay, I hope you got it. Moving on to the next question. 1:25. Okay, scale model of spillway is to be tested in lab. The discharge in the prototype is 900. Okay, cool. Next is model they want. Okay, model they want. Length scale ratio is 25. Cool. So we can use that that discharge scale ratio is length scale ratio raised to the power 2.5 when there is a case of Froude's law, which is spillway is obviously the case where gravity will be dominating, and when gravity is dominating we use Froude's number. So Froude's model law says this. So QP by QM is 25 raised to the power 2.5, where QP is given to me as 900, QM is required to be found out. So QM from here would be how much? 0.288. Cool, everyone got it? Superb, amazing. Next question. Okay, air passes over a thin plate of dimension 1.5 by 1.5 meter parallel to stream. Yeah, this is a beautiful question and I want to give this question as a homework to all of you. That is the reason why I kept it here. It's just a homework so that you can put this in the comment box. मुझे इसका आंसर comment box में ज़रूर देके जाइएगा. If you are watching it in the recorded form, then please pause the video and find out the answer and tell me in the comment box. I will answer this question in the comment box only as soon as I'll get the at least one answer from any of you. किसी भी एक बच्चे का आंसर आते ही मैं इसका आंसर आपको बताता हूँ उसमें. Yeah, I'll also share this in my Telegram group if you want. That is Civil by Ninja. This is the Telegram group that I am having. If you are not there, you can join. How many of you are not there? But sir, आप आंसर नहीं बताते. मैं आंसर अभी बता दूं. इसका आंसर है देखो 0.124 न्यूटन. और what else is required? Free stream velocity ना, that would be 5 meter per second. A इसका आंसर है. अब आप बताओ मेरे को ला पाओगे कि नहीं ला पाते हो. नहीं ला पाते हो then I'll share the solution in this Telegram group. थोड़ी देर में भेज दूंगा, पक्का प्रॉमिस एकदम. Next, a pipeline connecting two reservoirs has its diameter reduced by 20% due to deposition of chemical. So this is very common. Can you tell me what phenomena is this from environmental engineering? That is the reason why we have to do the recarbonation also. बताइए सर क्यों होता है ऐसा? For a given head difference in the reservoir with unaltered friction factor, this would cause reduction in discharge of how much? बताइए, are you sure? Okay. Okay, cool. So first the dia, initially let's say the dia was D only, but after that it became 0.8 D. Now we have to find out the relationship between the discharge and the dia, correct? So let's do that. So I think that's simple for us, right? Because we know that HF is equals to FLQ square by 12.1 D raised to the power 5. So we know what is the relationship here between the discharge and the diameter, right? So accordingly we can work on this. So D2 by D1 raised to the power 5 will be equals to how much? Q2 by Q1 power 2, right? Okay, we have to find out Q2 and then accordingly we can find out Q2 in terms of Q1 basically. Incrustation, yes, incrustation is the one thing that happens if there is more, I think, basicity. That is the reason why we do the recarbonation, so that that is the reason why there is no zero hardness in that method. Bataiye sir, how much is the value of Q2 in terms of Q1? So Q2 I think you will get from here na, D2 is 0.8 D by D, right, power 5 power 5. So class में कर दो. Okay, what else? From here we will get, so Q2 will be, I'll tell you how much it is, 0.57 of Q1. ठीक है सर, आंसर आपके सामने, ऑलमोस्ट सामने ही है. How much percentage it will come? 74.6, and percentage reduction they are asking na. So how much it will be? Are you sure? 74%? भाई तबीयत खराब हो गई है. Q1 minus Q2 by Q1 how much is this? Anyone? बोलो एक बारी कितना आ रहा है? 74.6 तो नहीं आएगा, 4 समथिंग कुछ आना चाहिए, 40 समथिंग. 43 I guess. 43%, yes, correct. Not 74. 42.75 or 43 will write, 43 only here. That anyways will be given in the question only, right? BARC में तो मिलेगा आपको MCQ solutions, I mean MCQ. Next question. A rectangular sharp crested weir with end contraction is 1.85 meter long. How high should it be placed in a channel to maintain an upstream depth of 2.35 meter for 0.5 meter cube per second? Okay, CD is given, G is given. Come on, go for it. NIT Suratkal machine design versus NIT Warangal machine design. Warangal, I would say. But it is not an easy choice, right? So head to head, but still Warangal has 1 point more than Suratkal. Then other things comes into the picture like the location and all. If whatever suits you, you can go there. हाँ जी सर, फटाफट से शुरू हो जाइए. So sharp crested, right? So Q. Suratkal पूछा ना? हाँ, Suratkal, yes, right. I thought I heard, I saw something else. CD under root 2G will be using L effective H raised to the power 3 by 2. Right, sir. So now here we first need to find out few things like L effective will be how many end contraction they are saying? with only, okay, cool, with end contraction they have said, right? Cool hai. So my rank is 2300. Should I do MTech from NIT Trichy? Kar lo yaar, it's good only. Abhi this question is not 0 or 1, black or white answer nahi hai iska. Ayush, that depends on you, a lot of things. For example, abhi I don't know about you, right? But if I take my example, then I actually will be very much furious to be financially independent. ठीक है, घर से मतलब पैसे ज़्यादा नहीं लेना चाहूँगा मैं. तो in that case I will go for the NIT Trichy thing. It's a very good college, obviously. One thing. Second is that ठीक है, कोई इतना problem नहीं है. Like you 1 more year you can go without that particular issue of finance and other things. Very good. Then no need to go. You can prepare. Solely depends on the condition of lot of other things. This is one example that I gave you of finance. This is L effective. So guys, this is the formula that we have to use. You can quickly tell me now. From here you are going to get the value of H. How much is the value of H? मैं बता देता हूँ भाई, calculation में ज़्यादा time ना waste करो. 0.25 meter. Right, but they are saying we have to maintain an upstream, how much? 2.35 meter, right? 2.35. Then you just have to subtract from this 2.35 minus 2.35 minus 0.25. So from there you will be getting 2.1 something. I think C is the right answer. Yeah, C hoga. No, is 5 is also there na, A. Last में 5 भी है ये वाला. So because of that it will be 2.10. Next question. A small orifice A and B of dia 1 cm, 2 cm are placed on the side of the tank at depth H1 and H2 below the open liquid surface. If discharge through A and B are equal and for some value, say same value of CD for 2 orifice, the ratio of H1 and H2 are X ratio 1. Find the value of X. My goodness. X को ढूंढना है सर आपको. चलिए. If I draw the diagram, it's an easy diagram. 2 orifice. Let's say free surface is this, H1 and H2. H1, H2, 1 centimeter, 2 centimeter. So we know that CD is, or discharge is CD A to GH, right? From here you will get the discharge dia. Cool. Now you can answer. निकाल भी लिया भाई साहब. सही है सर. So the discharge is same only, they are saying. So D1 square H1, D2 square H2, right? Now based on the changes, as you can see, 2 is the value of second orifice and the first one is having 1. The dia is given to you, right? So accordingly from there you will get the answer. H1 by H2 will be equals to D2 square by D1 square का whole square. So 4 का 16. So 16 should be the value of X. Got it? Superb. Next level. अगला सवाल. If the velocity divergence at a particular point and time is 3 meter per second and the rate of change of density is 0.9 kg per meter cube per second, then density at that point will be how much? बताइए सर. del rho by del t given है 0.9. हो जाइए शुरू. Divergence is also given. Very well. I hope you remember that divergence or vector form of continuity equation that I always tell you. d rho by dt, substantial derivative basically, plus rho divergence of velocity vector equals to 0. So rho we want, this is given, that is 0.9, this is given as 3, 0. How much is this? 0.9 by 3 minus 0.3. But can density be negative? Can density be negative? Tell me. Nope. So that is why the right option to be selected is B, 0.3, right? So that also we have to understand sometimes. Next. Super simple. Quickly answer. बता दो सर फटाफट से लाइन लगा दो. Hagen-Poiseuille's laminar-Poiseuille's flow between two parallel, the ratio of average velocity to the maximum velocity is how much? बताइए सर. Average to maximum. Cool. Two times? बताओ फटाफट. This is I think easiest question. ये तो बस as a revision I brought. Either A or D. Cool. That's D only. Done. Superb. So with this session, I think I was able to make you solve some questions of fluid mechanics. I'll see you in some other class again on the same channel. I hope you liked this video. If that happened, then don't forget to like the video. Okay, sir. I'll see you in the next session. Till then, please take care of yourself and please take care of your family. And have a nice day. Bye-bye.